Welcome to the 7th video in the series of videos on simultaneous linear equation. This is the second video on word problems. In the previous video we have done two types of problems. In this video we're going to look into another two type of problem. So here is one of them. This is an age problem, a typical age problem. I think the best way to start would be to kind of write the given information in this format. So you can write present age of A and B. So it's given A and B. So let's say they are X and Y. So the first thing given is, let's write what is given, right? X by Y is 9 by 4. And 7 years later, the ratio of the age is 5 by 3. So let's write 7 years later, A's age is X plus 7 and Y's age is Y plus 7. So you have X plus 7 divided by Y plus 7. That's equal to 5 by 3. So we can convert these into the linear equations. So you can say this is 4x equal to 9y, or 4x minus 9y equal to 0. So that's one. And the second one is 3x plus 21 is, so we cross multiply this. So we say 3 into x plus 7 is 5 into y plus 7. Or in other words, you say 3x plus 21 is 5y plus 35. Or 3x minus 5y equal to 14. So this being both your equations, I would urge you to pause this video here and try to solve both these equations. So you can solve this by any method, but here we have multiplied the equation 1 by 3 and the equation 2 by 4 and subtracted them. And there you go, you have y is 8 and x is 18. This implies A's age is x, which is 18, and B's age is 8. So that's your answer. Let's do another type of problem in the word problem series. So here's the next problem. This is a slightly tricky one, so let's do this together. So if A and B can do a piece of work in 15 days, so now how do you quantify the work, right? Because I could, let's say we quantify it as the work is W units. It could mean anything. Let's say you're building a wall. So, this wall has about W bricks. The number of bricks is W, right? This all adds up into W units, right? You can imagine something like this. Now, a piece of work, it can be completed by A and B in 15 days. So, A and B, it takes 15 days to finish this W unit of work. 1 day's work of A will be 1.5 times 1 day's work of B, right? So, and the question is, find how many days will each take to finish the work. So let's say if A does this work, this W units of work, A takes X days and B takes Y days to finish the work. So in 1 day, A will be able to do W divided by X units of work, and B will be able to do W divided by Y units of work. Now if A and B work together in 1 day, they can do W by X plus W by Y units of work, right? So we have this. So now, what can we do now? Let's take this previous statement. So it says, if A and B together can do a piece of work in 15 days, right? So if A and B together takes 15 days for doing W units of work, in one day they can do W by 15 units of work, right? And this is exactly same as this. So you have 1, 2. So this one day, in one day, A and B. So let's say A and B working for one day will finish W by 15 units of work, right? And this is equal to W by X plus W by Y, which is from 3. All right? So in other words, 1 by X plus 1 by Y is 1 by 15. So this is your equation 1. So let's further look at this problem. It says if 1 day's work of A is 1.5 times 1 day's work of B. So we know that one day's work of B, A, is W by X. 1 day's unit of work is 1.5 times 1 day's work of B. So that's 1.5 times 1 day's work of B. So in other words, you can cancel this, and you can say, hey, 1 by X minus 1.5 divided by Y equal to 0. So this is your second equation. So pause the video here and try to solve this equation. So you can solve this by substituting A for 1 by X and B for 1 by Y, and you get these equations, and you can subtract them to eliminate your A, and you can find the value of A and B. And once you find that, you can find X and Y. So A will take 25 days to finish work. That's because that's our assumption. A takes X days, so X is 25, and B will take 37.5 days to finish the work. So I hope you enjoy this problem. So this marks the end of the series of videos on simultaneous linear equation. See you in the next one. Bye.